Okay, Dylan draws up a plan to fence in a yard for his chickens. The distance between grid lines is 1 foot. Is 30 feet of fencing enough to enclose the yard? So that's question one. So if we're looking at that question, is 30 feet of fencing enough to enclose the yard? What is it they're asking me to determine?
How much fencing we need.
Which would be what geometric calculation?
Maybe area.
Area would be fencing, or would it be something else? So we want to know how long the fence is.
Slope.
Well, we might use slope at some point, but we're trying to calculate things about a shape. We got area and what else? What's the other thing we can find for calculation?
The lengths.
The lengths, which is, if we want the length around a figure, what's that called? Perimeter, all right? So we have area, we have perimeter. Those are the two calculations we make with geometric figures, right? So if they're asking how much fencing we need to enclose this yard, we're looking for the length around the shape. That's the perimeter of the shape, right? So as far as that question is concerned, I need to know the length of AB, BC, and AC to find the length of each side, right? We're in coordinate geometry. We have coordinates representing those positions, so we have the distance formula to tell us those exact numbers. It says each grid line represents a foot, so if this is 2 feet, 6 feet, 10 feet, 12 feet, 10 feet, 2 feet, then we're just looking at all feet here, and we don't know if 30 feet of fencing is enough. You can notice that B and C are vertically positioned from one another, so again, if there's no slant to the line like we saw yesterday, we don't have to use the distance formula, we can just count. So from 10, 12 to 10, 2 is 10 spaces, so that's 10 feet. Right. Obviously, I don't know what AB or BC is. They're both slanted lines, and I'm going to have to use the Pythagorean, or sorry, not the Pythagorean theorem, but the distance formula. So if I'm looking at AB, and I want to know the length of AB, the distance formula is and always will be just this structure. And the only two things you need to know is how far are the x's and how far are the y's apart from one another. So I'm looking at points A and B, and the x's are 2 and 10. How far is it from 2 to 10?
8.
8. How far is it from 6 to 12?
6.
6, right? So again, all we have to do is just, if I'm here and I want to go there, how far did I go, right? So the x goes from 2 to 10, which is 8 spaces. Y goes from 6 to 12, which is 6 spaces. We square both numbers, that's 64 and 36. That gets me the square root of 100, which is 10. So AB is also 10 feet. And finally AC. And we're trying to find the length of a segment, so we're using the distance formula again. AC, we're going from 2 to 10, which is 8 spaces. We're going from 6 to 2, which is 4 spaces. That gets me the square root of 64 plus 16, which is the square root of 80. A little bit less than 9, but I'm going to use a calculator here. Square root of 80 is 8.94 feet. So again, this is Dylan's chicken yard that he's got figured out, right? And we need 30 feet. He has 30 feet of fencing. We want to know if he has enough fencing. If we add up the 3 pieces, it looks like he needs 28.94 feet. So the perimeter is equal to 28.94 feet. So he has enough fencing. As far as that part of the problem is concerned, we got that under control. The second part of the problem, if we keep reading, it says, for a healthy flock, each chicken needs at least 8 square feet of space. What is the maximum number of chickens Dylan can put in the yard? So if each chicken needs at least 8 square feet of space, space has to do with how much room is inside the figure. So Perimeter is how far around the figure is. Square feet come from area. So if we're looking at this amount of space in here, every chicken needs 8 square feet of space to be able to run around. If you get too many chickens in there, you get population density is too high. So basically, we want to make sure that each chicken has at least 8 square feet of space. So we need to know the area of this thing. Now, this is an isosceles triangle. There are a couple ways to find the area of this. For me personally, this is just me looking at this. If I see a vertical or horizontal line, I'm going to do it this way that I'm going to show you right now. If you want to have one way to do every problem in this section, you can just use that matrix technique we've been using, the 1/2 times the matrix, and do all your multiplication. But when I have a vertical or horizontal line, like we have here, just highlight that line, go with a blue. That's a vertical line. It's very easy to make a perpendicular off a vertical or horizontal line. And if I go perpendicular to the other vertex, so this is vertical, this is the third vertex, that right there is perpendicular, and I can very easily determine the length of that line just by counting, just like I counted this was 10. If I count this out, it's 1, 2, 3, 4, 5, 6, 7, 8. And those are perpendicular to one another. So the area of this chicken yard, the area of triangle ABC, is just going to be 1/2 times the base, which I'm making the vertical line, the base, times the height, the segment perpendicular to the base, which is going to be 1/2 times 10 times 8, which is going to be 40 square feet. Okay, that's the easiest way to find area if you have a horizontal or vertical line. Right? Again, you can do that matrix, it would work, it would get you the same answer. All right, so 40 square feet is the amount of space in the entire chicken yard. Every chicken needs 8 square feet of space. So one chicken is going to use 8 square feet. So you just take your area, multiply by that fraction. The square feet cancel the square feet, and 40 divided by 8 gives me 5 chickens. So if you just imagine chicken A is using up 8, there's still 32 left. Now the second chicken uses 8 more, now there's 24 left. The third uses 8 more, now there's 16 left. Fourth chicken uses 8 more, there's 8 left, and the fifth chicken uses the last 8. So there's 5 chickens can fit in the yard for a healthy flock. So 5 chickens is the answer to part B. In general, know how to find the area and perimeter of any figure in the coordinate plane. All right, and again, interpret the questions as to, does this ask me for perimeter, is this asking me for area, if they're giving you questions in that general framework.